Hi everyone, in this video I'll walk through my BubbleSort design space exploration for HLS in Cyber Workbench. First I start with the original BubbleSort.c without any pragmas. I run the HLS synthesis to get the baseline numbers. I'll show you the synthesis result. Uh, this design is fully sequential, and so it uses the moderate amount of um, ALUTs and registers, which is 578, 171 registers, 571, 578 ALUTs, and has highest latency 9.5684. I use this baseline as a reference point for comparing the next pragma combinations. For the second case, you can see I'll just analyze this. So the second case here is where I set my array equals to RAM pragma for pragma, and the other two pragmas unroll times equals to all for both the loops. You can see here in the synthesis window. Let me synthesize this and generate RTL. Okay, this is the summary. Latency has significantly decreased compared to the baseline because full unrolling creates parallel compare swap units. However, since the array is stored as RAM, the register usage is lower, but ALUT's count goes up due to the logic required for unrolled loops. This design gives a good balance of memory, efficiency, and high parallelism. So let me show for the second design. The registers, let me change this to REG space, okay, and second pragma to all and third pragma to 0. Let me save it and analyze, synthesize, or generate RTL. Here unroll times all on the outer loop and unroll times 0 on inner loop. This means the inner loop runs sequentially. When I synthesize, the results show that this version uses least area. The LUTs you can check out of the three designs which I've discussed before, because it has less hardware replicated. However, the latency is highest because the inner loop operations occur one at a time. This design is ideal when we want to save area and don't need high performance. These are the other parameters where you can check. Let me go to the final design where you can see pragma 1 is REG and other two are fully unrolled. And let me save this. Okay, analyze, synthesize. This design consumes highest amount of ALUT since unrolling the inner loop replicates a lot more hardware. This design shows the typical trade-offs in HLS. More unrolling equals more speed, but also higher area. From all three designs, we can clearly see how pragmas affect hardware. Full unrolling improves the performance but increases area, and partial unrolling or using RAM instead of REG saves resources but increases latency. To explore more hardware variations, we could also try partial unrolling like unroll times 2 or 4, which offers middle ground performance. We could also enable loop pipelining, which overlaps the iterations and increases throughput without fully duplicating hardware. Finally, this concludes my design space exploration. Thank you for watching.